I'm going to talk about optimal climate policy, but before I do that, I'm going to review what is in the international agreements on climate policy about the targets for greenhouse gas emission reduction. The United Nations Framework Convention on Climate Change was negotiated in 1992, and its Article 2 says that the ultimate objective is to achieve stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. Such a level should be achieved within a time frame sufficient to allow ecosystems to adapt naturally, to ensure that food production is not threatened, and to enable economic development to proceed in a sustainable manner. And it's very hard to disagree with this, and that explains why the UNFCCC was quickly negotiated and quickly ratified. It is now international law. And it's hard to object, as I said. The aim is to prevent danger, which is always good. The second sentence actually specifies what is meant by danger. The first subclause says that ecosystems should adapt naturally. That is pretty vague what is meant by that, and if you ask free ecologists what this means, you would get 17 different answers. And of course, we know that climate change has been very, very rapid in the past during the Younger Dryas, during the Heinrich events, and those sort of things. And ecosystems made it through that, and they seem to have adapted to naturally very rapid climate change. So it's unclear what sort of constraints this imposes. Second subclause is that food production should not be threatened, which is always a good idea. We all like to eat. But it does not specify the nature of that threat. Is this a threat posed by climate change, or is this a threat posed by climate policy? And of course, biofuels at the moment directly compete with food production. And therefore, climate policy can be argued to threaten food production. Climate policy, not climate change. And similarly, we want economic development to proceed. But again, the nature of the threat is not specified. Is this the threat of climate change, or is this the threat of climate policy? So people on the green scale, people who are environmentalists would get behind this, but also people who are very conservative would get behind this and can interpret this in a radically different way. And this is, of course, the art of diplomacy, to use language that everybody can get behind. And that immediately implies that different people would read different things into these words. So it doesn't mean much, or does it? I haven't talked about the word stabilization. Let's assume that this is a model of the atmospheric concentration of carbon dioxide. So the concentration is denoted by m, and that happens at time t. And this is a function of what was previously in the atmosphere. A part of that disappears, that's the parameter delta here, and of course we add through our emissions. So let's assume that this is how the carbon cycle works. Now, what does stabilization mean? Stabilization means that concentration doesn't change. That is, mt is equal to mt minus 1, but if the concentration doesn't change, then t is essentially irrelevant, and you might as well throw away your subscript. And then we have the equation, m is delta m plus E, or m is E over 1 minus delta. So essentially what this means is that if you want to stabilize the concentration, you should stabilize emissions. But as we could not agree on what level concentration should be stabilized at, we also cannot agree on what level emissions should be stabilized at. Now that assumes that this is the appropriate and adequate representation of the carbon cycle. It isn't. What you're looking at here is a cartoon of the carbon cycle. It is a pretty complex picture. In reality, the carbon cycle is a good bit more complex. So what is going on? In the squares that you see here, these numbers are the stock of CO2 measured in petagrams of carbon. And what this means is that there's around 1700 petagrams of carbon, stored in the permafrost, and about the same amount on the ocean floor in the form of sediments. So that is what the squares mean. The arrows are fluxes. So what you see here is that volcanoes emit around 0.1 petagram of carbon per year on average. That's the black numbers. There's also red numbers here. The black numbers indicate the situation as it was in pre-industrial times, say 250 years ago. The red numbers are the change since pre-industrial times. And one thing that we notice, and that is of course what we're primarily interested in, is the emissions from the combustion of fossil fuels, and that amount to 7.8 petagrams of carbon per year. And that is completely new, that wasn't there in pre-industrial times. That also has implications for the stocks. So the black numbers is the CO2 that we had in fossil fuels, and the red number here is what we have burned since the start of the Industrial Revolution. And what you see is that there's a good bit of CO2 left in the ground for us to burn if we so wish. More arrows here. One thing that you see here is the natural, is the emissions from the terrestrial vegetation, and of course that is offset by the annual uptake by the the terrestrial vegetation, and the same is going on in the ocean, where you have a large annual outflux, but also a large annual influx. These numbers here are pretty large, 120 or so, and here's 80 here, compared to the 80 that we saw here. The natural fluxes are much larger than fossil fuel combustion, but they offset each other. There's about 80 going out, and there's about 80 coming in. There's about 120 going out, and there's about 120 going in. But there's nothing that immediately offsets these emissions here. Now there's one arrow that I haven't mentioned, and that is the one that you see here, and that is rock weathering. Rocks interact with the atmosphere and they take out some of the CO2 that is in that atmosphere. And this happens at a very slow rate. This is essentially the rate at which rocks grow, which from a human perspective is very, very slow. And that is the key to understanding the next set of equations. In a paper published in 1988, Ernst Mayr-Reimer and Klaus Hasselmann, who you see here, argued that there isn't really such a thing as the atmospheric concentration of carbon dioxide. Really, there are 5 separate concentrations, and what we observe as M is really the sum of 5 M sub i's, and let's call them boxes. And they further argued that each of these boxes is governed by a first order linear difference equation. That is, MIT is delta I, MIT minus 1 plus alpha ET. So there's a bit of CO2 in this box, and that depends on how much was there in the previous year, and some of that disappears. And then we add to that, and we need to partition our emissions according to the 5 boxes. And then, of course, in order for this to make sense, these alphas need to add up to 1. What they do. And then what they found, that if they calibrate this model, then the first delta, which is governs some 20% of emissions at the moment, has a characteristic lifetime of 2 years. That is, if you put 100 tons of CO2 into this box, then 2 years later 50 is left, 4 years later 25 is left, 8 years later 12.5 is left, and so on, right? So that is what this number means. There's another bit that has a characteristic lifetime of 17 years, and there's a bit with a characteristic lifetime of 74 years, and a bit with 363 years, and a bit that is essentially rock weathering, that on a human timescale doesn't degrade at all, that just stays in the atmosphere forever. Delta is 1. Now we have a problem, because we said that stabilization means that M is E over 1 minus delta, and if delta is 1, we're dividing by 0. And that is not something that is advisable. But of course there's an alternative solution to this equation. M is delta M plus E, If delta is 1, this says that m is m plus E, or E is 0. Stabilization of the atmospheric concentration of carbon dioxide means that emissions have to go to 0. And this is what was agreed in 1992 and written into international law in 1995. Emissions should not be cut in half, emissions should not fall by 80% or by 90%, no, emissions should go to 0. Article 2 of the United Nations Framework Convention does not specify how fast or by when, but it does specify that emissions have to go to 0, and this has been international law, as I said, since 1995. The Paris Agreement, it's an agreement under the UNFCCC, in 2015 actually puts more concrete numbers on this. And Article 2 again, Article 2.1a, to be precise, of the Paris Agreement stipulates that this agreement aims to strengthen the global response to the threat of climate change by holding the increase in the global average temperature to well below 2 degrees Celsius above pre-industrial levels and pursuing efforts to limit the temperature increase to 1.5 degrees. That is what has now been agreed internationally. And the question is, where does this 2 degrees come from? Well, this is a somewhat older target. It was first adopted by the Scientific Council Global Environmental Change of the German government in the middle of 1995. It was adopted by the German government at the end of 1995, and a few months later in the Spring Council by the European Union. It was reaffirmed by the European Union in 2005. Then President Obama, but never the US government, embraced it in 2008, and then in the Cancun meeting in 2010 it was more or less adopted as the United Nations target, and then further codified in the Paris Agreement of 2015. So that is where the 2K target comes from. The 1.5K target doesn't have any such backing. It appears to be an entirely arbitrary number. The 2K target is also suspect. So how did the WGU derive this number? Well, they did it in 4 different steps. And the first was that they tried to do a cost-benefit analysis, and I'll show you another cost-benefit analysis in a minute. But in that cost-benefit analysis, they arbitrarily exaggerated the economic impact estimates. So the best estimate at that time was 1 to 2% of GDP for a doubling of the atmospheric concentration of CO2. No, it was 1 to 2% of GDP for the 2.5 degrees increase in global mean surface air temperature. And they said, well, this number is too low, let's make it 5. Without any evidence whatsoever. They also talked a lot about ecological impacts, the impacts of climate change, of biodiversity, and those sort of things, but they never actually specified these things. This was entirely a hand-waving argument. They also write explicitly that they set this target so as to safeguard creation. Now, this is an official body of the German government, and the German government, by its constitution, is secular. It's not a Christian government or an Islamic government. No, it is a secular government, one thing. And the W in WGU stands for scientific. So it is very peculiar that a scientific advisory council to a secular government talks about such things as creation, which is a fairly religious concept. And they literally say this. Of course, not literally because they wrote in German, but if you translate, then it's what they said. And they sort of operationalized this whole notion of safeguarding creation by referring to the historical record. The argument was that as a species, Homo sapiens has never experienced temperature swings that are much more than 1.5 degrees above the then or the current temperature. And then they said, well, 1.5 is perhaps a bit stringent, let's make it 2. But the argument is entirely backward looking. Essentially, the argument was that humanity should not experience things that it has not historically experienced. And one of the things that humanity has never historically experienced is to be free of racism or free of sexism or a fully democratic society. And they're apparently dead against that. Of course, throughout history, infant mortality has been very, very high, and apparently they are also against lowering infant mortality. So very strange arguments. The reason that this particular advice was adopted by the German government was essentially because the chair of the committee was close friends with the then environment minister, Angela Merkel, who pushed this on her government, and then the German government pushed this onto the European Union, and then for a very long time this was the only target around, so people started believing, yes, this is the only target around, so it must be the right target. There have been later attempts to justify the 2 degrees targets, but they're all flawed. So it's essentially an arbitrary number.